Now whenever we talk about HCF, what does it mean by HCF? We know that HCF is highest common factor, and LCM is what? We know that lowest common factor. How to calculate HCF? We know that the common matter is, if the two numbers are there 16 and 20, what is the HCF? We just have to take the highest common factor. Highest common factor. We don't have to multiply the common factor by uncommon factor. This is what in LCM, but this is not in HCF. We just have to take the common factor. In 16 and 20 common factor, we know that 2 8s are 16, 2 10s are 20. Again 2 is a common factor. 2 4s are 8, 2 5s are 10. Now for 4 and 5 there is no any common multiple which can divide both these numbers. So 2 into 2, 4 is the HCF of 16 and 20. If someone asks you to calculate the LCM, then let's see how to calculate the LCM. I told you how to calculate the LCM in the LCM videos, but here also I will tell you how to calculate the LCM, so you can get the difference between LCM and HCF. This is what HCF, highest common factor. Just take the number which can divide both this number. 4 and 5, there is no any common factor between them, so we just have to stop here to calculate the HCF. But for the LCM, take again, we know that there is no any common factor, so take again. So take 4 ones are 4 and 5. Take again 5 ones are 5. So the LCM will be 2 into 2 into 4 into 5. Means 2 into 2, 4 4s are 16, 5s are 80. So 80 will be the LCM of this number, and HCF is 4. Means what? Please watch it carefully. In LCM there is 4. Means what? In LCM there will be the HCF into the remaining factors. 2 into 2 into 5. Okay, this is very important. So let's see. I want to clear down some common concepts in HCF, so you can solve any example on HCF. If I say there are the two numbers, one number is 24 and another number is 18. Now let's see. If you take the LCM of both this number for the 24, 2 2s are 4. Okay, 2 2s are 4, 3s are 12, 2s are 24. And for 18, we know that 2 into 3 into 3, 2 3s are 6, 3s are 18. So LCM will be, here LCM will be, these are the common, so take 2, again 3 common, take 3, then take the uncommon factor, 2 into 2, and this 3, so 3, so 2 3s are 6, 2s are 12, 2s are 24, 3s are 72, so 72 is the LCM, 24 and 18. And HCF, what is the HCF? We know that in HCF we just have to take the common factor. We know that the common factor here is 2 and 3, so 6 is the HCF of 18 and 20. Now let's see, if I multiply both these numbers, n1 into n2 is equal to, one number is 24, another number is 18. So 24 18s are 432, and if I multiply the LCM into HCF of 24 and 18, we know that the LCM is 72. So 72 into HCF was 6, so 6 2s are 12, 7 6 are 42, and 1 43. Please watch it carefully. N1 into N2 we got 432, and LCM into HCF we got 432. The same is here. So from this I can conclude that N1 into N2 is always equal to LCM into HCF. This is very important. Please note it down, because on this formula we have to calculate a lot of problems on LCM and HCF. So this is very important formula. The multiplication of two numbers is always equal to the LCM multiplication of LCM and HCF of these numbers. So N1 into N2 is equal to LCM into HCF. This is very important, please note it down. Now let's see here the two number was. Okay, I quickly repeat what I did here is. So two numbers was there, 24 and 18. Okay, we took first the LCM of these numbers, means what? The common factor into uncommon factor. 24 factors are 2 into 2 into 3 into 2, and 18's factors are 2 into 3 into 3. For the LCM, we first took the common factor 2 and 3. Then we took the uncommon 2 into 2 into 3, 2 into 2 into 3. We got the LCM as 72 of 24 and 18. Then we took the HCF is equal to only common factor, HCF only common factor. So this 2 and 3. So 2 into 3, 6 we got here. So we multiply both these numbers, and 1 into n2 is equal to 24 into 18 is equal to 432, which we got here. And then we take the multiplication of LCM and HCF is equal to 72 into 6. This 72 and this are the 6. Again we got the 432, which is similar of the multiplication of these two numbers. So the n1 into n2, we can conclude that the n1 into n2 is equal to LCM into HCF. So this is very important, because based on this there are a lot of examples which we have to solve. So please note it down. Please note it down on paper. n1 into n2 is equal to LCM into HCF. Now let's see. 24 and 18, these are the number which we took. Okay, the common factors are, here we know that 3 into 2 into 2 into 3, no? 3 2s are 6, 2s are 12, 2s are 24, right? And here again 3 into 2 into 3, right? So let's see, please watch it carefully. We know that here LCM, how we have calculated, we know that how we have calculated the LCM here. Take the common factor 3, 2, then take the uncommon factor 2 into 2 into this 3. In this way we calculated the LCM. But we know that the HCF was only common factor, means 3 into only common factor 2, 6. These 6 are here, 3 into 2. 3 into 2, these 6 are here, means what? I can write it down as HCF into 2 into 2 into 3, means what? This 6 into 2 into 2 into 3, means what? 3 into 2 into 2 into 2 into 3. So I got here LCM is equal to HCF into, this will be the factor 2 into 2 factor of this 24 number, so I can write it down as F1, and 3 is the factor of 18, so I can write it as F2. So we can conclude that the LCM is always the multiplication of the HCF into factor 1 and factor 2. So this is also very important, please note it down. This is also very important. Means what? The LCM include the HCF, multiplication of the LCF, and the remaining uncommon factors of the numbers. So LCM is equal to HCF into F1 into F2. This is very important. Now let's see, the number 1 is this number 1, 24. I can write it down as HCF. We know that the 6 into, okay, 6 into, these are the common factors, these are the uncommon factors, means what? F1 is the factor of first number 2 into 2, so 2 into 2, so 6 2s are 12, 2s are 24, means what? We can conclude that n1 is always equal to HCF into factor 1, factor 1, factor 1, factor 1. Number 1 is always equal to HCF into factor 1. Similar for number 2, we know that number 2 here is 18, so similar for the number 2, HCF into factor 2, means what? HCF, what was the HCF? 6 was the HCF, 6 was the HCF, so 6 into, what was the factor 2? You know, this is the factor 2, this was the factor 2, so 6 into 3, 18. Similar number we got here, so I can conclude that, I can write it down it as n2 is equal to HCF into factor 2. This is also very important, please note it down. These 3 important formulas are there which are very important. LCM is equal to HCF into factor 1 into factor 2. Number 1 is always equal to HCF into F1 and number 2 is always equal to HCF into F2. F2 means factor of number 2. Factor of number 2. These are very important formulas. Please note it down. And again, the important formula I am going to tell you. The summation of two numbers n1 plus n2 is always equal to HCF of factor 1 plus factor 2. Means what? Number 1 plus number 2 is equal to HCF into factor 1 plus HCF into factor 2. You can check it. We know that the two number was the 24 and 18. We know that the HCF was 6. Factor 1 was 2 into 2. 2 into 2 was the factor 1. So I can write it down 2 into 2, 4. Plus HCF, we know that the HCF was, which we have calculated here, 6. So I can write it down as 6 into factor 2 was 3. Let's see. The factor 2 was 3. So I can write it down as 3. Let's see. 24 and 18 are 24 plus 18. 42 and here is similar. 6 4s are 24 plus 6 3s are 18. Again 24 plus 18 42. So this is also very important. We have proved it that summation of two number is equal to HCF of F1 plus F2. So this is very important also. N1 plus N2 is equal to HCF of F1 plus F2. This is also very important. So in this video what we have learned is number 1 into number 2 is equal to LCM into HCF. This is very important. Please note it down. Again, LCM is equal to HCF into F1 into F2. Again, number 1 is equal to HCF into F1. Number 2 is equal to HCF into F2. And summation of the two numbers means N1 plus N2 is equal to HCF of F1 plus F2. We have proved it. So these are the very important. Based on this we have to solve a lot of examples in the next video. So please note it down, these important formulas.